solve a fractional equation today, and we're looking for positive real valued solutions. Now this x, a member of R plus, is just another way of saying x is a real number greater than 0. Okay. Now let's review this fractional part, this kind of squiggly brace thing here. Just a concrete example here, if you wanted to look at, say, the fractional part of, let's say, 6.8. Now we all know what the fractional part is. It would just be 0.8. The fractional part is a number between 0 and 1. Okay, so we know that this is equal to 0.8 or 4/5. Okay, but let's just, I'm developing this little result here that's going to make life a little bit simpler. What you can do right here is just notice that in this particular case, I would be 6, right? And so you would have that this is equal to 6.8 minus 6. Now this definition turns out to be more useful than x minus the floor, in my opinion. And I'll put 0.8 for emphasis here. And again, 0.8 is the same as the fraction 4/5. Okay, so again, you'll find this definition is quite handy as we move into the problem here. Now let's move on down. Now, if you just subtract I from both sides, you get this statement right here. In other words, if we subtract I from both sides of this inequality, we get that 0 is less than or equal to x minus I is less than 1. And of course, we recognize that as the fractional part, okay? So this piece right here is the very same thing as the fractional part of x. All right, so the fractional part of x, you know, and you know this, it's kind of dreary here, isn't it? The fractional part of x is definitely a number between 0 and 1. And so that explains why this statement right here would imply this, right? Because this piece right here is always stuck between 0 and 1. That implies this inequality right here. Notice how this piece just disappeared, and x squared itself has to be trapped between 107 and 108. Simply because, let me just write this down here, maybe it'll be a little more clear. This piece right here is strictly, it's less than or equal to, I'll just write it down. Less than 1, right? Okay. And so if this squared fractional part is bounded below by 0 and above by 1, that means we can write this equality as this inequality. Okay, and from there it follows immediately when you take squaring is a increasing function. So if you square root both sides, you get this. So you get x is strictly or x is greater than or equal to the square root of 107, and it's bounded above by 108. Okay, it's not super important here. Now notice that x is greater than, strictly greater than 10. Okay. X is strictly greater than 10 since x is greater than or equal to the square root of 107, right? And the square root of 107 is certainly greater than 10. So that's where this 10 comes from right here. Okay, again, from this statement that we have. All right, so now we have a concrete expression, a concrete simple linear expression for the fractional part of x. All right. Now the rest of this is just fairly routine. I left out some of the details, but the fractional part of x squared is the same thing as x minus 10 quantity squared. If you go through all the arithmetic here, the algebraic aspect of this, you get this quadratic, and it's actually easier to complete the square right here. It's much easier to complete the square in this particular case. You know the usual recipe of taking half squaring, then correcting your mistake. That's where the 25 plus 4 comes into play, and you get to 29. Okay. Now notice we are looking for a positive solution. Remember at the beginning of the problem we stipulated we're seeking x greater than 0. All right, now the square root of 29 is greater than 5. So the only solution here, the only possible solution here would be x is equal to 5 plus root 29. 5 plus root 29. Again, we reject the negative solution since we're just seeking positive solutions. And the square root of 29 is larger than 5, which means 5 minus the square root of 29 would be negative, right? All right, let's keep going. Now, y'all, let's check it. Okay, some people just quit right here. I notice a lot of the channels just quit and say there's the answer. But this is our original equation, right? And so here's the check. Now again, this is, all I did was x squared right here. Now remember, the fractional part is x minus 10 for this problem. So this would be x minus 10 quantity squared, which is the same thing as the fractional part squared. Okay, that's the definition we've seen, right? So this is x minus 10 right here. All right. And again, when you do all the arithmetic, you get this. And notice how the 10 root 29s do cancel. And what we end up here, folks, is 29 and 25 is certainly 54. Okay. And again, the third portion of this cancels nicely, so we get plus 54 again over here. Plus 54. And that does equal to the 108 that we anticipated. Okay, so the check, it checks out. Let's do check. And now we can conclusively circle this as the answer. 5 plus root 29 is the solution. And we never had, from a decimal point of view, we never had to know what the fractional part really was. It would be, let's see right here, the fractional part would be according to, well, it's not important right now because we just solved the problem, we just checked it. But anyway, that we never directly found the fractional part, but we verified that what was represented as the fractional part solves the equation, okay? Again, we could work this for negatives too. This I member Z, this is any integer, so it works for negative integers. And we could look for an x that's negative also. But anyway, this is the last, this is the answer. I hope you enjoyed.